Very good morning, my dear students. Today we are going to discuss Unit 4 Air. The topic is composition of air. Students, in the previous class we discussed Joseph Priestley's experiment. From Priestley's experiment, which was followed by Ingenhousz and Rutherford, we came to know that air was not just one substance. We will now describe that air is made up of, this is called composition of air, because air is made up of so many gases. The major component of air is nitrogen. Almost 4/5 of air is nitrogen. The second major component of air is oxygen. About 1/5 of air is oxygen. In addition to nitrogen and oxygen gases, air also contains small amount of carbon dioxide, water vapor and some other gases like argon, helium, etc. The air may also contain some dust particles. What is the major component of air? Nitrogen. Second major component? Oxygen. Okay, students. So, air is a mixture of various gases. The composition of air changes slightly from place to place and also from season to season. For example, air over industrial cities usually has a higher amount of carbon dioxide in it than the air over open spaces. Air in coastal areas may have more water vapor than inland areas. Air also contains more water vapor in rainy season. The amount of dust in the air is more in windy places than other areas. You might have seen the sunlight entering into a dark room through a narrow slit and making shiny dust particles dancing merrily on the path of the sunlight. See the dust particles. Actually, the air in a room always contains some dust particles, but they are so small that normally they are not visible to us. When a beam of sunlight falls on them, the tiny dust particles become visible. Okay, students. Next, shall we discuss one activity? Okay. The activity is calculate the amount of dust particles in air from our area. In this activity, we need one graph sheet. Take a graph sheet using marker pens. Draw a 5 into 5 centimeter square on the graph. See 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, like 5 into 5 centimeter square on the graph. Apply a thin film of grease on the graph sheet. So, in this graph sheet, we are applying grease on the graph sheet. This sheet will serve as dust collector. Make 4 or 5 graph sheets. Place the dust collectors in agreed positions. Ensure that the dust collectors do not get blown away. After the time scheduled for performing this activity is reached, remove the paper and count the number of collected dust particles in the marked area in all the sheets. Using a magnifying glass at the dust collector, we can see something similar to the diagram here. Then calculate the mean number of dust particles in the marked area is equal to, the formula is total number of dust particles on collector. Collector means that graph sheet by number of squares on collector. Okay, so what is the formula we are using to calculate the mean number of dust particles? Total number of dust particles on collector divided by number of squares on collector. And the range of the dust can also be calculated as given below. Range is equal to maximum value minus minimum value. Collect details from all the areas where we have kept the dust collector sheets. Tabulate the recordings in the table given below. Okay students, so this is the method we are calculate the dust particles in air. Next, test for water vapor in air. Take a few ice cubes in a glass. Keep it on the table for a few minutes. Observe what happens. You could see tiny droplets of water all over the outer surface of the glass. From where do these droplets come? The water vapor present in the air condenses on the cold surface of the glass. This shows that air contains water vapor. Next, burning and combustion. When we burn a candle, paper, kerosene, coal, wood or cooking gas, oxygen is needed. The oxygen needed for the burning of candle, paper, kerosene, coal, wood and cooking gas comes from the air around us. In rockets, as they go high in the atmosphere, the availability of oxygen is considerably reduced. Therefore, in rockets, along with the fuel, oxygen is also carried for combustion. So thus, for burning a substance continuously so as to make fire, a continuous supply of fresh air is needed. If we cut off the supply of fresh air to a burning substance, then the burning substance will not get oxygen necessary for burning to continue and hence the substance will stop burning. See, in this activity, look at the picture A. This is a burning handle. And in the next picture, we are place an inverted glass jar above the candle. What happens? The first candle only glowing, but the second handle is put off because here inside the glass jar no oxygen is there. Okay, so for any substance burning means oxygen gas is necessary for a burning process. The process of burning a substance in the presence of oxygen and releasing a large amount of light and heat is called burning. If the process does not emit flame, then it is called combustion. Okay students, so I hope how to calculate the dust particles in air and test for water vapor in air and burning and combustion. Thank you children.